Hello students, how are you all? Today we'll discuss about the acceleration due to gravity and gravitational constant. Gravity means small g, gravitational constant capital G. We will discuss about them and also we'll derive a relation between the small g and capital G. So, let us start with a question. Say I have got a ball. Fine. This is the ball which I am holding here. Now, what is the velocity of this ball? 0. Now I am just leaving the ball. Now the ball is falling. Do you think that throughout the whole journey the velocity of the ball will remain same each and every point? No. Do you think that the velocity will decrease or velocity will increase? You understood my question? When I am holding the ball here and when I am leaving it, when it is falling, then its velocity will gradually increase. Yes. Here, when I was holding the ball, the velocity of the ball was 0. Now, when I am leaving it, from 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In this way, the velocity will increase. Understood? And we know that when velocity increases, that means some acceleration is there. Yes. When this velocity is increasing, means an acceleration is also there. This acceleration we called acceleration due to gravity. That is small g. Understood? So small g is the acceleration due to gravity. Now you got the idea what is small g? And capital G is gravitational constant, which already we discussed. The link of that video is there in the description box. You can check it out. So we got small g and capital G. Small g is the acceleration when an object is falling, freely falling, then its velocity increases gradually. Who increases the speed? That is gravity, acceleration due to gravity. Understood? Now we will see the relation between small g and capital G. Correct? For that, we'll consider, say this is the earth surface. Earth. Capital M is the mass of earth. This is the center of earth. So this is the radius of earth. Capital R. Got it? Capital M is the mass of earth. This is radius of earth. And this is the center of earth. Fine. Now, say, here is an object. Small object whose mass is small m. Now, according to the Newton's law of gravitation, I mean universal law of gravitation, we can say that if F is the force of attraction, then we can say that capital F equal to capital G, capital M, small m by this distance square. Distance square. What is the distance here? The distance is from center to center. Center of this object to center of earth. Say this height is h, small h. Now what is the distance between this object to the center of the earth? The distance is this much. That is capital R plus small h. Understood? Capital R plus small h. Fine. Because according to Newton's law of gravitation, we know that force equal to capital G, capital M, small m by distance square. Distance means center to center. Center to center. Now if you measure center to center, this much is small h and this is capital R. So capital R plus small h whole square. Fine. Now also we have derived a relation in our previous video whose link is also there in the description box. Force equal to mass into acceleration. Already we derived it. Force equal to mass into acceleration. Fine. So now for this object, when you are holding the object, when you are just leaving it, what happens? The ball falls down. Yes, falls down. And while falling down, its velocity will increase. And the acceleration we call acceleration due to gravity. I mean small g. And from Newton's second law of motion, we have seen that force equal to mass into acceleration. Fine. Now, when the object is falling here, so what is the acceleration? That is gravity. So instead of acceleration, I will write gravity. Understood? So we got two equations, equation 1 and equation 2. Fine. Now we'll come to this equation. Instead of capital F, we'll write small m small g. Small m small g. Fine. G m m by. Now say this is the ball, or say this is the pen. I'm just holding this pen here. Fine. Where I'm standing on the earth surface. Fine. I'm standing on the earth surface and this is the pen I am holding. What is the height of this pen from the earth surface? Maximum 2 meter or 3 meter. Fine. That is height of this pen from the earth surface is 2 meter or 3 meter maximum. Now if I ask you what is the radius of earth, is much higher than this height. Got it? Actually what I want to say you, this is the radius of earth and this is the height of this object from the earth surface. Understood? H is the height of this object from the earth surface and capital A is the radius of earth. Understood? So capital R is the radius of earth and small h is the height of the object from the earth surface. Now which is greater? Radius of the earth is greater. Much greater than the height of this object. So capital R is much higher than. That's why I have given two greater signs. See. Capital R is much higher than this capital H. That means in front of this capital R, this small h is just nothing, ignorable. So we can ignore it. So instead of capital R plus h, we just can write capital R square. We can ignore this small h because this small h is much less than the radius of earth. Fine. Now we'll continue this equation. We'll cut small m from both the sides. What we are getting? Small g. Here I am writing small g equal to capital G, capital M by capital R square. Capital G, capital M by capital R square. Fine. So gravity, I mean acceleration due to gravity is equal to gravitational constant into mass of the earth and radius of earth. This is the relation between acceleration due to gravity and gravitational constant. Correct? So this is the relation. Now, we know the value of capital G. I told you in the previous value 6.67 into 10 to the power minus 11. Mass of earth, radius of earth, if you put this value, then you will get the value of gravity on earth's surface. Let us find it. So, what is the relation between small g and capital G? The relation is small g equal to capital G, capital M by capital R square. Fine. Now let us consider earth. What is the mass of earth? Yeah, you can see that the mass of earth is 5.96 into 10 to the power 24 kg. 5.96 into 10 to the power 24. This is the mass of earth. What is the value of gravitational constant? 6.67 into 10 to the power minus 11 by. What is the radius of earth? Radius of earth is 6.37 into 10 to the power 6. 6.37 into 10 to the power 6 meter. But this is square. So that's why again you have to write into 6.37 into 10 to the power 6. Now if you calculate whole this, if you are calculating this multiplication, then this exponents and all, you will get 9.8 meter per second square. Yes, this is the value of acceleration due to gravity on the surface of earth. Got it? This is, we can say, on the surface of earth, it's 9.8. Now let us see what is the value of gravity on the surface of moon. Now to find the gravity on the surface of moon, we'll just put the value of mass of moon and radius of moon. So what is the mass of moon? First let us put the value of capital G. 6.67 into 10 to the power minus 11 into. What is the mass of moon? Yeah, you can see that 7.36 into 10 to the power 22. 7.36 into 10 to the power 22. Now 1.75 into 10 to the power 6 into 1.75 into 10 to the power 6. Why I have written it twice? Because r square. Now, if you calculate all this, the whole thing if you calculate, you will get 1.6 meter per second square. So, I have shown you how to find the value of gravity on Earth's surface. Just you have to take the value of mass and radius of Earth, and we have also seen the gravity on the surface of moon by using mass of moon and radius of moon. You can calculate the value of gravity for other planets also. Yeah, like Jupiter or Saturn, any other planet. Just you require the mass and radius of that particular planet. Understood? Thank you.